back to our channel. My name is Teacher Smith and we are discussing past paper challenges. The question that we are going to discuss today is from NMOS 2019 and the topic that we are going to learn today is TN model. Now what's so special about this model? If you see recent past papers in 2011, 2019, 21 and 22, application of TN model was used. And one pattern you can observe, recently there have been 3 of the questions in the last few years. So what is TN model? Let's try to understand first. So out of this, the question that we have selected today is question number 7 of 2019. This is the question. Let's read it once. The question says, the rectangle shown is separated into 8 right angle triangles by line segments. The area of 3 of the triangles are indicated in the figure. What is the area of the entire rectangle? The question is asking us about area of the entire rectangle. Now if you observe the figure carefully, this figure is made up of how many rectangles? Oh, it's made up of 4 of the rectangles. Now if you observe the first rectangle over here, the area of half of the rectangle is given. It's a diagonal, due to which half of the rectangle it's given as 4 centimeters. The other rectangle, half of the rectangle is given as 6 centimeters. The other rectangle, half of it, the area is 12 centimeters. We need to find out entire rectangle. For that, we need to first find out what are the areas of this empty spaces that we have. Now if you observe, if half of the area is 4, the other half will be also 4. This means we can find out area of the first rectangle, that is here. For the second one as well, half of the rectangle is 6, the other half will be, of course it will be again 6, and the area of total rectangle will be 12. Quite simple, right? Moving on to the next one. Here half of it is 12, the other half will be 12, total is 24, we can get the area. But the challenge lies here. For this rectangle, what we can observe is we need to find out area of this rectangle. How to find it out? For that, we are going to use TN model. So first things, what we need to understand is when to use TN model. Here we have 4 of the rectangles, and in this 4 of the rectangles, some of the sides they share is in common. Some sides are common, right? So now we are going to use TN model. For that, let's understand TN model first. Let's say I have again 4 of the rectangles in such a way that they share same sides. Now, if I name the sides here for the rectangle A, if I name the sides as A and width as B. For the other half, if I name the side as C and the side of C as D. Now if I ask you, can you tell me what is the area of this rectangle A? What is the area? Yes, area of A is nothing but length times width. Length is A, width is B, so area will be A times B. Now moving on to the next area, that is B. If I want to find out area of this rectangle, what it will be? For that we need length. What is the length here? Oh, this length is same as the length that we have, that is A. So for B, the area of rectangle B will be A times C. Now for area C, let's observe. If I want to find out area, the same thing, that is length times width. Length is D, width is B, D times B. And for D, the area is nothing but D times C. Now I want you to observe carefully. Observe carefully what we can observe here. Oh, we can observe A and A. Side A is same for both the rectangles A and B. And here, what we can observe? Side D is same for both the rectangles C and D. Now, let's say if I divide them, since A and A is same, if I divide area of A and area of B, what will I get? A and A will be cancelled out. I'll get B upon C. Perfect. Moving on to the other half. Here we have SC upon SD. If I divide them, what will happen? D and D will be cancelled. Again, I'll get B upon C. So here, in the first part, I got area as B upon C. Here, also for area of C and D, it's B upon C. B upon C, B upon C is same. So what can I say? Oh, we can see area of A upon area of B is equal to area of C upon area of D. And if I write it down linear, we can see it is area of A multiplied by area of D, which is equal to area of B into area of C. Now observe this areas. Area of A and area of D. What is the relation of rectangle A and rectangle D? Oh, it forms a cross. It forms a cross. This means the area of A is nothing but the product of the other rectangle, but it is present at the opposite direction. Similarly, area of B and area of C, the product is present in opposite direction and the product is same. This product is same. This is nothing but called as the TN model. Now why it's called as TN model? Because it resembles quite similar to a Chinese letter, Chinese character TN. That's the reason why we call it as TN model. Now, how to identify TN model and how to use it? In a figure made up of 4 or more rectangles which share common sides, the product of areas of 2 opposite rectangles are equal. This is what the TN model says. So, whenever you see a rectangle, a figure made up of 4 of the rectangles, and there is a relation between area, you can use TN model comfortably. Now, going back to our question. Here, first things first, we need to find out areas of the remaining part. So if I find out, if this is 4, the other half is 4, perfect. This is 6, the other half is 6. This is 12, the other half will be 12 for this rectangle. And if you try to find out areas of this rectangles, it will be, for the first rectangle it is 8, the second rectangle is 12, the third rectangle is 24. Now to find out area of the entire rectangle, we need to find out area of this part. What we should use? Perfect, we need to use TN model for that. So for TN model, we know the product of opposite rectangles is equal. So opposite rectangle, the opposite rectangle to 8 is, it's 24. So 8 multiplied by 24 is equal to 12 multiplied by the rectangle that we need. And if you find it out, it's 8 multiplied by 24 divided by 12, which is nothing but 16. So the area here is 16. But what we need to find? The entire figure. For the entire figure, what we need to do? We just need to add it. So area of the entire figure is nothing but equal to 8 plus 12 plus 16 plus 24. And if you add them, it's nothing but equal to 60 centimeters square. So here in this question, we saw that finding out the other parts of the areas was quite simple. But for the last rectangle, what we used? We use TN model. Remember when to use TN model? When we see 2 or more rectangles that share the same common sides, we can find out the relation between the areas. And what is the relation? Yes, the product of the opposite rectangles is equal. So currently we saw what is a TN model from just one of the past paper. We'll be doing more of such past papers and practices and covering more such topics in our class. For that, we are enrolling in term 2 and term 3. Yes, the enrollment starts for term 2. The lesson starts from 25th May. And if you want to sign up for my lessons, here is the QR code that is present. You can scan the QR code to book a free diagnostic test for Maths Olympiad with me. The address given is our current address where our center is. You can come down to the center to give the entrance test to register you for the current classes. For now, I am Teacher Smith signing off right now, but I'll see you in my next video.